In this video, we're going to talk about the chemistry of the atmosphere, going from the Earth's early atmosphere to the present atmosphere and showing what climate change is and how it's been affected by our behaviour and carbon footprint. So, first of all, we had this big ball of molten rock billions of years ago, and that big ball of molten rock started to cool. Now, do not worry about the physics of this. This comes from the Big Bang theory in terms of a huge explosion, and then that explosion just calms down slowly over time. And the nuclear reactions inside of the Earth are what keeps the Earth a similar temperature. And of course, the sun will make that effect too. But right at the start, we've got this molten rock that's cooling down. Now, as it cools down, it will start to form a crust around the outside. So the rock will start to solidify around the outside, a bit like a glass or a cup of hot chocolate. When you leave it for too long, you get the skin across the top, or milk. And so basically it starts to solidify like that. Now, it has weak parts in it, and the weak parts mean that you start getting these things, which are volcanoes. So volcanoes start spewing out lots and lots and lots and lots of gas and lava and all of this kind of stuff, because it's just weak points in that crust. Now, if that is the case, let's put those volcanoes onto the Earth. When we put those volcanoes onto the Earth, again, this is not to scale, so please don't look at it and think this is to scale and there's only 4 volcanoes. There'll be loads and loads of volcanoes. And plus, they'll be a lot smaller than this. But just to make the point, these molecules are the ones that are given out primarily. And ammonia and methane and water are given out in small amounts relative to this one, which is CO2. Now, this atmosphere is very similar to what Venus's is now. So you may see questions comparing this to Venus's atmosphere now. But it is a high carbon dioxide atmosphere, 97%. Remember, everything in green in these videos is some things you definitely need to remember. Then the Earth cools further. Remember, you've got a load of gases out of there now. So those gases here have all come out those volcanoes, and they're filling the atmosphere with these different types of atoms. Now, those atoms, carbon, oxygen, hydrogen, nitrogen, again, all the ones which make up amino acids. So if you've done your biology course, you'll know about amino acids. And amino acids are the building blocks of proteins, which are essential for us to live. So this was the building blocks of life that started. Now, it cools further, and it cools to a point where the water that's been given out starts to condense. And when water starts to condense, it creates clouds. And when the clouds get too full of water, they start to release that water in the form of rain. Now, the Earth was not a round ball. It was just a lumpy round ball with lots of divots and dents and things like this. Now, those are filled in with the water that is raining for a very, very long time. And therefore, you get your oceans. Now, next point. At this point, you are going to get a lot of carbon dioxide in the atmosphere. Now, that carbon dioxide is precipitated. That means it turns into a solid, okay, when it reacts with the water. So it dissolved in the oceans and then starts to react in the oceans to form, for example, things like calcium carbonate. And again, in green, this is for your exam. You definitely need it. Okay, so it produces these sediments, and those sediments can be incorporated into living organisms in the ocean. And those living organisms go on to create oil. For example, they sediment down to the bottom when they die, and then they get buried for millions of years, and it turns into our oil. Now, from this point, we then get to this Earth, which you recognise as the Earth we've got now. And it's green. And that's the big thing, it's green. So that means we must have, from this point, have some life, and we have some life in terms of photosynthesis. But I want to talk about how you get from here, okay, to here. So this is our approximate amount of nitrogen in the atmosphere now. It was much less than 3% here, it's now 80%. Then you go to the oxygen, again, much less than 3%, now 20%. Okay, and then that amount of carbon dioxide. Again, that's approximate because it changes and varies ever so slightly all the time. And again, argon at the bottom, which is and some noble gases. Now, we have to get from here to here. And how did we get from here to here? Well, first of all, we had to build life. So life had to happen because life is what is going to do respiration, it's going to do photosynthesis. But for start off, the most important one is photosynthesis. So we've gone from here to here, 97% to 0.04, and that means the carbon dioxide and the oxygen has gone up and the carbon dioxide has gone down. And that is because of photosynthesis. So algae developed, which photosynthesized, plants then developed, then we're getting onto trees, and all of those photosynthesized to differing amounts. And if we mess up that environment, we're going to mess up this balance. And we need this balance to be able to live. So it's very important that we keep this similar to what it is today. But we're going to go on about that in a little bit more detail later. But also the carbon was trapped, and it's really, really important here. The carbon was trapped underneath the earth, or in the earth, or in organisms, through oil. So remember I said that the carbonates were precipitated out of the ocean. Carbonates were taken up by living beings. Those organisms then died, goes to the bottom of the ocean, and then they're sedimented and buried for millions of years, and that becomes oil. So that means that contains carbon, which takes carbon dioxide out of the atmosphere, which takes the 97% down to the 0.04. And the same happened with coal, but coal is made from plants, trees that have been buried for a very long time. Okay, and that would take the carbon out of the atmosphere, and the gas as well as a byproduct of the oil, essentially. So all three of these, fossil fuels essentially, takes the carbon out of the air as well. Photosynthesis takes the carbon out of the air, and photosynthesis actually introduces oxygen into the air. And the oxygen's going up to get this, and the carbon dioxide's going way down. Okay, right, next part. Remember, that is approximate, and you need to remember it. To those people who are looking at that going, that's not the actual amount of nitrogen. Okay, it is 78%, it is 21%, but in this course, it's approximate. So we've got some photosynthesis that is taking in the carbon dioxide, trapping it in the trees, trapping it in the plants, okay, and then giving out oxygen. We've got the fossil fuels that have trapped the carbon in them from the atmosphere, okay, and the last thing, which you'll need to know for your exam, is that the carbon was actually trapped in sedimentary rocks. It doesn't take a lot to go to sedimentary rocks because a sedimentary rock that you can have is chalk is used, okay, and marble, which is a similar thing, just more compact, essentially. That's one example, and you can see that big carbon right in the centre. So basically it was made from the carbon dioxide. That carbon dioxide then changed into carbonates in the ocean, which precipitated, turned into a solid, and then starts to sediment. Okay, so those carbonates that sediment then form the sedimentary rocks, and the pressure over millions of years pushes it together to make your strong rock. And that's because originally the CO2 dissolved in the oceans. Now, if we look at photosynthesis in a bit more detail, you have to remember this equation. So if you're doing notes here, you have to remember this equation. Now, it's easier than it looks. So the photosynthesis is using up carbon dioxide and it is giving out oxygen. So the oxygen level is going up and the carbon dioxide level is going down because it's all trapped in the trees. And they grow and they take more in and they give more out. But then we've gone in green here for the 6, 6, 6. And I teach my students the devil is in the detail. Okay, so the devil is in the detail, and that means basically the devil's number is 6, 6, 6. So it's quite an easy one to remember, photosynthesis, just basically the conversion of carbon dioxide and water through light absorbed by the plants, and that's all we need to know for our chemistry GCSE, going to make that oxygen. And that's because of all this evolution, this plants, trees and algae. So we're now going to look at the Earth's present atmosphere and how we've affected it with the burning of fossil fuels and our behaviour. Now, just a very quick summary, going from that molten rock, the molten rock of the original Earth cools down, you get the crust, you get the volcanoes, all these chemicals come out, which are the building blocks of life. Most of it is carbon dioxide, much like Venus. You get 97%, cools further, rains a lot, fills in all the little divots and dents and things like that, creates our oceans. Most of the CO2 dissolves in the oceans. Then, from that point, that CO2 reacts with the water and then starts other reactions that form these carbonates. Those carbonates are used by living organisms. Those living organisms then die, fall to the bottom of the ocean, and then get buried over millions of years. That turns into our oil, and the trees do exactly the same thing, fall over, die, but they get buried and they turn into coal. Okay, and with the oil comes the gas as well. So just a very quick summary there. Okay, but we're going to look at what effect we've had. We're going to bring the Earth up here, our current Earth, and you see our current Earth, lovely in green. So we've got that photosynthesis, the trees, decreasing the carbon dioxide for us, increasing the oxygen for us so we can breathe, we can live. Okay, we know it's approximately 4/5 nitrogen, we know it's approximately 1/5 oxygen. Okay, so a really nice mix so we can live. And if we disrupt that, we are in trouble. Now, carbon dioxide is going up currently, and that is because of combustion. So, we are burning trapped carbon in the form of oil, trapped carbon in the form of coal, trapped carbon in the form of gas. All of that is being burned, and the CO2 is increasing because when you burn something, you create CO2 and water. CO2 increases, and that increases the warming effect on the planet. There are other greenhouse gases as well, but the main one we're making an effect on at the moment is CO2. So if we go to the greenhouse effect, the actual warming of the Earth and what's happening here, you've got combustion of those fossil fuels, which is releasing the trapped carbon in terms of CO2. Now the greenhouse effect is basically the atmosphere here, and that atmosphere is warming up. Now it's warming up because of things that we do and have done and can change. So there's a really positive thing about this is that we can change it. It's just whether we decide to do it and how quickly we do it. Now, here we have you, us, everybody. We're the ones that are making this impact. And we do that through burning of oil, and we do that through burning of coal and gas as well. Okay, and we also do it through our lifestyles. So our lifestyles are driving cars, gas guzzlers and things like that use lots and lots of petrol. So we're moving to electric, and it's how quickly we move to electric. And then that electric has to be produced in a way that doesn't use up carbon. So it can't be made in a way, for example, where traditional power stations where you are burning coal. Okay, it's got to be made in more environmentally friendly ways, and then we've got to figure out what those ways are, and we are doing it at the moment. Perhaps not quickly enough, but we are doing it. It's the fuels we use in our homes. Are we using environmentally friendly fuels in our homes? And that's becoming a hot talk of debate over the last few years. Now, one big thing is flying. Now, very recently, a plane flew with fuel that had already been used up for cooking, and then it was no longer any good, and then they put it into a plane. So things are happening with planes. But people can always look to see whether they lower their imprint in terms of, and carbon imprint in terms of planes. So we're going to talk about carbon footprint right at the end. And these are the things you can change. So for example, could you change your car? Could you change the fuel you've got at home? Could you fly a little bit less, or fly you can environmentally, okay, in terms of where you go and what you do, a little bit less distance and things like that. But we have to fly because the world relies on it. So you can't stop everything you do. You've got to make it so it's better to fly, not necessarily stop flying completely. Now, let's have a look at this in a little bit more detail. Here's the kind of effects that you're going to have. And this is a real problem that may happen in my lifetime. Okay. And if you look here, all of these are releasing that carbon dioxide, the carbon dioxide, but there is a load of trapped methane inside of this ice cap. And a huge amount. And we know that one of the effects is if you get a global warming of the entire Earth, you may start melting this. And it's already melting. You'll see loads of videos online of glaciers falling into the sea and things like that. That's not just releasing land ice into the sea, which would make the sea level rise. It's only land ice that makes the sea level rise in that way, although you can get expansion of water due to increase of temperature. Okay, But you've got here land ice falling into the sea, and inside that land ice is trapped methane. Methane is a greenhouse gas, so is water. Okay, so it's not just carbon dioxide, but carbon dioxide is the main one we're making an effect on, but methane could be the next one we make an effect on if we cause the change that melts that polar ice cap. Now, let's talk about this in another bit of detail. It's about how you eat. So you've got here a lovely cow, and we in the world, certain countries eat a lot of meat and certain countries eat far less meat. So for example, there are areas of India that are completely vegetarian, and but the Western world is largely meat-based. Now that means that cows release a lot of carbon, and they also take a lot of carbon to feed and bring up. Vegetables are a lot less in terms of the carbon footprint, how much carbon is released when making something. Now, if we now start to take all of this into effect, okay, you can now see that this is heating up the Earth. So let's look at the actual effect itself. So here you have, in the end, I've left the us on because we are the ones making the change. I'm going to come over here. So this time you've got the sun. So this is the sun, and all the radiation from the sun is coming out here and coming to us. It's being absorbed by the Earth, okay, and then some of that energy is re-emitted, okay, and re-emitted, right? Now, to maintain our temperature, a certain amount has to be emitted, re-emitted out to the atmosphere and out into space. However, these compounds especially, and there are others as well, but these compounds especially, block that. They absorb that energy, and then it gets forced to go back into the Earth and essentially warmed up the Earth. And that's the greenhouse effect. It's almost like a barrier here, and that's why we call it the greenhouse, like the world is in a greenhouse, okay, stopping the heat from escaping because the heat is trapped by these molecules. So what we do is we have to lower this molecule and this molecule especially, okay, we have to lower those so that the heat is not trapped as much, and then the global temperature should go down, which is why we need to stop releasing trapped carbon. Now, if that is the case, let's move that up there. Okay, there is a summary of what we're talking about here. So most wavelengths of the electromagnetic radiation pass through the Earth's atmosphere. So most of them go through. Some are absorbed, but you don't need to know that in detail. Earth absorbs most of the radiation, warmed up. It radiates it back out as infrared radiation. Infrared lamps are red, so we put it in red. Okay, and some of the infrared radiation goes into space. Some of the infrared radiation is absorbed by the greenhouse gases in the atmosphere. It's stopped from going out into space, and so the lower atmosphere warms up. And since 1880, the atmosphere is warmed by 1.1. Now, I did tell you today that just in the news when I'm recording this video, there's been an average of 1.5 over this year so far, which is very, very dangerous. So we need to do something very quickly about fossil fuels, how we deal in them, how we create our energy, and how we lower the amount of carbon in our atmosphere. So we're now going to talk about the effects of climate change and then go on to talk about carbon footprint. We'll also do a quick summary. Now, polar ice caps melt. That's because the global temperature is going to go up. If they do melt, we're going to release lots of methane. That methane is a greenhouse gas. Okay, so that is going to raise the global temperature even more. Now, that's already happening. Increasing sea levels, that can happen because of expansion of water, because the global temperature is going up, and as that happens, the water will expand, but also the fact you've got land ice coming from the polar ice caps. Now, all of this, there can be something done about it, so please don't think I'm being doom and gloom. Okay, that can cause flooding in certain areas because you have excessive weather events. So you get rain in a lot of rain in a very short period of time, and then you can get, and this leads to a reduction in biodiversity, and also that reduction in biodiversity is caused by us. So, for example, we do palm oil plantations in certain areas of the country, of the world, and those palm oil plantations are required by other richer countries to make their foods. And so it's actually the richer countries that are causing the problem because they're providing the demand for this. Okay, so we need to make sure that when we're doing our food, that we do it in a sensitive way to biodiversity and not destroying biodiversity. And there are examples of that happening around the world. The question is just, is it happening quickly enough? You get famine and drought in some countries, so you get dryness in some, you get lots and lots of rainfall in others. Okay, so there are all of your effects, but I wanted to take a very short period of time to talk about the average temperature change globally, but I'm not really talking about that average temperature change in terms of what it is, because you already know from 1975 it's gone right up there. So you can see 1975 at the bottom, you can see the increase here. So how much has the global temperature increased? Okay, it starts off around there and then starts going up, 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 up. Now, the important thing I want you to look at is this: 6 different sources. 6 different sources, and each of those is a different colour, and they're all generally following the same trend. Now this is really, really important. So what's really, really important about this is a question that comes up in the exam. Now we know most increase has been made since 1975, and they've used peer review here, and that's the key thing, this peer review. A scientist cannot just produce data and then tell everyone else to accept it. That scientist may have been funded by a company that wants them to say certain things and might influence them in a certain way. So what we can do is compare scientists' results and see whether we come up with the same results. And this study has 6 different sets of data from lots of different places and different countries. So you can see NASA, you can see Japan, okay? And so it's from different countries. Different countries have different perspectives on things, different pressures. So the wider you have the data from more different sources, this peer review means you will avoid bias. Bias being, I don't have the money in my country to stop using fossil fuels and invest. Okay, so I want fossil fuels to continue, so I might want to carry that on. Okay, so it's really, really important that you get rid of this bias. And you get rid of that bias by doing peer review. And this is a 1-mark question in an exam, which most people get wrong. So if you ever have a question that says, why was this data not accepted? It's because they didn't compare it to experts and scientists' data, okay, and therefore it could be biased. Why was this data accepted? Because they did peer review, and this data is generally accepted because they did peer review, and therefore there's no bias. We're now going to do a quick summary of everything we've said, okay? It doesn't include absolutely everything because we cannot fit it on this slide, but it does 90% of it, and that's what you'll need to know in the exam. So, ball of molten rock, Earth cools down, gases given out. Okay, those gases are the building blocks of life: nitrogen, hydrogen, carbon. Most of the gas is carbon dioxide, so you get a high carbon dioxide atmosphere just like Venus. Earth cools down, oceans are formed, water vapour condenses, fills in all the gaps and creates your oceans. Most of the carbon dioxide is dissolved in the oceans, and you form carbonates that are precipitated, producing these sediments that fall down and are taken in by living organisms. That means the CO2 decreases. Now, from that point, you get photosynthesis, living plants, trees, algae, all that kind of stuff starts photosynthesizing. CO2 further decreases and the O2 increases. You get further development of life, and you get the Earth we've got today now, and then we start combusting the fossil fuels. So we start combusting the fossil fuels. CO2 is starting to increase again because of these fossil fuels being combusted and producing carbon dioxide. There's lots of different effects, okay, including polar ice caps melting and all of that, okay, but we need to stop burning these fossil fuels if we want to maintain this level of gas in our atmosphere and not increase the carbon dioxide to a point where the Earth warms too much. Now, I did that really, really quickly, and if you try and do it yourself, you will get it into your head. So stop the video and just try and talk through it really, really quickly and go through it. It's a really good way of revising. Now, the last thing we're going to do is carbon footprint. So carbon footprint is something you can measure. So carbon footprint is just how much carbon you give out in your daily life. Now, you as a person give out a certain amount of carbon, which goes into the atmosphere, doing your daily things. For example, taking a 5-minute shower instead of taking a 20. Things like that. Now, the activities you do, like I said, showering is one of them, and the objects you get affect that. So planes, cars, what car you buy, how many plane trips you do and how long your plane trips are, things like that. Also, little changes. Remember, I don't want to make you feel guilty about any of this. Just choose to do small things. And those small things can turn into big things, or they can just stay as small things. It's fine. But one of the big things is we've done over the last year or so is straws. So we've gone from plastic straws to cardboard straws, or using recyclable metal straws that you reuse over and over and over and over again. It's a bit like the adage where one person says, "What does my one straw matter?" said 8 billion people. So if one person makes a change, other people can make a change. It makes a huge difference. Now, in different regions and different countries, they have different carbon footprints depending on who they are. The Western countries have a higher carbon footprint than other countries. Okay, and that depends on how your energy is produced. So we need to produce energy in a different way, but that's your government. And then that's how we eat. So if we eat meat, perhaps switch to some vegetarian foods at some point. Now, this tells you how much carbon you release into the atmosphere as part of your daily life, and there will be questions on this in the exam-style question video and the worksheet that follows this video. Okay, but if you want to get the link to find out your own carbon footprint, it will be on the worksheet. Okay, so you can use that, and there are many of those online to calculate your carbon footprint, and then you can consider how you can reduce it. Even in a small way is good. All right. So, last thing, write down your own summary from the video. So stop the video right now. Now, check your summary. Make sure you've gone through the whole summary through the video, and you can get most of this on a half page of A4. It doesn't have to be huge. Right, my quick summary doesn't include absolutely everything because I've only got so much space on here, but I'm going to show you how quickly you can do it. Earth is a ball of molten rock. It cools, crust forms, volcanoes give out gases, and there are all those listed gases here. Earth cools more, water condenses, and it rains to form the oceans. Then you get gaseous CO2 dissolved in the oceans, which means the CO2 goes down. Then CO2 in the water form carbonates that precipitated, producing sediments. Those were used by organisms, and then that turned into oil and gas, and then the trees turned into coal. Now, CO2 is removed by the forming of sedimentary rocks and fossil fuels, so that's what I just talked about. Photosynthesis caused oxygen to increase, carbon dioxide is further decreasing. Burning of them caused carbon dioxide to increase, leading to the greenhouse effect and climate change. Effects include all of those underneath. So you see how I've written it really quickly in a short period of time, but the important bit are the green bits.